Hi. We're finished with Jess and Layla's astronomical assignment, so we're going to move on to Our Mysterious Universe. It's by Laura Langston, and I'm not sure why the screen is not matching up completely, but the rest of the pages do, so I'm not going to worry too much about it. All right, Our Mysterious Universe. You can see that there is a table of contents. It's not really set up in chapters, but it's set up in sections. I'm going to read the section, and then if there are comments or captions, I'll read those after I'm done reading the main text. Our Mysterious Universe. This was written in 2005, so it is 15 years old. 2005. I saw that right down here, 2005. Okay. And we've got the table of contents again with a picture. And then it should begin our text. Yes. All right. Our Mysterious Universe. For thousands of years, people have watched the night sky from groups of stars or constellations. They have formed pictures of animals, objects, gods, and ancient heroes. They have observed the paths that stars follow in regular cycles. They've used these star motions to find directions, to tell time, and to plan for planting, harvesting, and flood seasons. They have worked to explain unpredictable events such as streaks of light across the sky. They have asked questions such as the following: what are we looking at? How can we explain the motions we see in the sky? Where did these celestial bodies come from, and where are they going? By the way, a celestial body is just anything out in space. So a planet, a meteor, a comet, and stars. Throughout the ages, people have used their skills and have made tools to help them answer questions about the night sky. Today, our understanding of the universe is based on knowledge accumulated from data collected using technologically advanced tools from astronomers' use of the scientific process. On page 4, just above the picture of the night sky, the caption says, "The night sky has been a source of wonder and mystery to observers for thousands of years." On page 5, in the black box, it says, "The scientific process." Scientists use the scientific process to discover laws or patterns in the universe. First, they ask questions and make observations. Then they develop a hypothesis or possible answer to their questions. They test their hypotheses with experiments. Finally, they use the data from experiments to develop a theory, which is a likely explanation of their observations. The caption just below that says, "Astrolabes were first used by astronomers and navigators in the 600s to measure the position of the stars, sun, and planets." The other caption under the telescope says, "The telescope was first used to study the sky in 1609. Telescopes gave astronomers larger views of celestial objects and revealed far more detail." Much of what we know about planets and stars began with observations of how things work on Earth. For example, the regularity of the seasons was used to support theories about the way the sun revolved around the Earth. We have begun to understand more about the vast reaches of space and the smallest particles of matter, yet we find that the universe may follow laws that we can't explain using our common Earth sense. Every day, we continue to use our intelligence, new tools, and the scientific process to explore this vast system that is our mysterious universe. The solar system. In ancient times, people explained the universe by what they observed in the sky. The motion of the sun, the moon, planets, and stars, for example, made Earth appear to be at the center of the universe. There was a problem, however. Not all of the planets moved smoothly across the sky. Some appeared to reverse direction now and then. How could this be? Ptolemy's universe. Ancient Greek astronomers worked hard to understand this mystery. Their work was expanded upon by Claudius Ptolemy. He was an astronomer, mathematician, and geographer who lived in Egypt during the 2nd century. Ptolemy studied heavenly bodies. He even wrote a catalog of 1,025 stars that is the basis of today's modern star catalogs. He used observations and mathematics to prove that the Earth did not move, rather that it sat at the center of everything. This Ptolemaic system was accepted in Europe as fact for about 1,400 years. On page 6, just above those white pods, the caption says, "The twin Keck telescopes are located on the summit of Mauna Kea in Hawaii, United States, high above the cloud and water vapor of the lower atmosphere." On page 7, at the top, the caption under the grassy picture says, "Stonehenge in England was used as an astronomical calendar, its huge stones aligned with the sun." And the caption on page 7 under the diagram says, "According to Ptolemy, the sun, the moon, planets, and stars all rotated around Earth." Revolutionary ideas. The Renaissance brought changes to the ideas about the motion of celestial objects. In 1543, Polish scientist Nicholas Copernicus, he lived from 1473 to 1543, proposed that the sun, not the earth, was at the center of the universe. This idea was very disturbing to many people. Wouldn't it make sense, they reasoned, that the place where they lived was at the center of the universe, as ancient philosophers had taught? Other scientists made observations that supported and further developed Copernicus's hypothesis. Using a telescope, Italian scientist Galileo Galilei, 1564 to 1642, observed that the phases Venus goes through could mean only one thing, that Venus orbits the sun. Later, a German astronomer, Johannes Kepler, 1571 to 1630, discovered that all planets follow elliptical shaped paths around the sun. As a result of their work, these and other scientists developed the idea of a solar system that was sun-centered. They suggested that 6 planets, Mercury, Venus, Earth, Mars, Jupiter, and Saturn, orbited the sun. Formation of the solar system. Astronomers today know there are more than 6 planets. Uranus was discovered in 1781, and Neptune's existence was confirmed in 1846. Astronomers have also developed a theory to explain how the sun and planets formed. According to the nebular hypothesis, the sun formed about 5 billion years ago in the hot, dense center of a spinning cloud of gas and dust. Around that center, gravity pulled together tiny particles of gas, dust, and rock into grain-sized lumps. Slowly, these lumps, called planetesimals, joined together to form planets. The planets all traveled in the same direction around the sun at different speeds and at different distances. They were all held in place by the sun's strong gravitational pull. The caption under the small picture on page 8 says, "This 17th century illustration shows a plan of the solar system with the sun at the center." At the bottom is the nebular hypothesis. Step 1. The solar system started as a massive spinning cloud of gas and dust. Step 2. Gravity caused the sun to form and the cloud settled into a disk. Step 3. Planetesimals formed in the disk. Step 4. Planetesimals joined together to form planets. The caption under the Viking probe says, "Robotic space probes have visited all but one of the planets and many of their moons." And the black box says, "The force of gravity." Gravity played a large role in the formation of our universe and continues to affect its fate. Because of gravity, all objects are attracted to each other. More massive objects, such as the sun, attract more strongly than less massive objects, such as the planets. The closer 2 objects are to each other, the stronger the pull of gravity will be between them. These ideas, which make up the laws of gravitation, were developed by Sir Isaac Newton. He lived from 1642 to 1727. Newton was the first to recognize that gravity explains why objects fall, as well as why objects such as the moon are held in orbit around other objects such as Earth. Planetary bodies. The four planets closest to the Sun, Mercury, Venus, Earth, and Mars, are called inner or terrestrial planets. They are made of rock. They are also smaller than the outer Jovian planets, Jupiter, Saturn, Uranus, and Neptune, which are mostly made of gas. These huge outer planets are also called gas giants. The inner and outer planets are separated by the asteroid belt, a band of many millions of smaller objects called asteroids, or minor planets that orbit the Sun. These asteroids can be anywhere from a few hundred feet wide to several hundred miles wide. According to one hypothesis, most of the asteroids in this belt are the remains of a planet that failed to form. Many asteroids also exist outside the belt. The puzzle of Pluto. Scientists believe that Pluto is a small, cold ball of rock and ice. When it was discovered in 1930, it was the ninth planet from the Sun. Then, in 1979, something extraordinary happened. Its orbit took it closer to the Sun than Neptune was. In 1999, it crossed back over into the ninth place. Scientists now realize that because of the shape of Pluto's orbit, for 20 years during each of Pluto's 248-year orbits, Neptune is actually the furthest planet from the Sun. Pluto has other peculiarities. Its moon, Charon, is half as big as Pluto. None of the other planets has such a relatively large moon. Pluto and Charon are locked together, orbiting around a common center of gravity. As a result of these and other discoveries, many scientists believe that Pluto is a minor planet, like an asteroid. Others call this trans-Neptunian object one of many frozen objects orbiting the Sun in the Kuiper Belt. This is a flat belt of icy objects beyond the orbit of Neptune. Scientists believe objects in the belt are left over from the formation of our solar system. On page 10 in the black box, there is an alternative theory. A few scientists disagree with the nebular hypothesis. They think the planets formed when a cloud of gas and dust passed close to the young Sun and lost some of its material to the Sun's gravitational pull. For years, the only way to test these origin theories was to use data gathered from observing our solar system. Recently, however, astronomers have found other stars with orbiting planets. These discoveries may help us learn more about the origin of our own solar system. At the bottom, there's a diagram of the solar system. We have the Sun, Mercury, Venus, Mars, Earth. I read that out of order. It's Sun, Mercury, Venus, Mars, Earth. I did it again. Mars does not, I have to use my finger. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. It happens, right? On page 11, under that dark picture, the caption says, "This picture of Pluto, left, and its moon, Charon, right, was taken by the Hubble Space Telescope." That's a telescope that's not on Earth. It's actually out in space taking pictures from space. Comets, occasional visitors. Spectacles in the solar system, such as comets and meteors, were a great mystery in ancient times. They were believed to be signs of future events on Earth. Comets are balls of snow, ice, and dust that have changed only slightly since the Sun and planets were formed. Some orbit the Sun in the Kuiper Belt beyond Neptune. Most are even farther away at the edge of the solar system, where they orbit the Sun in a huge region known as the Oort cloud. Now and then, a comet is pulled by a passing star into an elongated orbit that takes it near the Sun. The solar heat quickly turns some of the comet's snow to a gas. The comet's glowing head is then followed by two long tails of gas and dust blown back behind the comet by the Sun. The glowing head and tails make the comet visible from Earth. Shooting stars and meteorites. Meteors, or shooting stars, are sudden streaks of light across a starry night sky. They are the result of dust or debris from a comet or asteroid that burns up as it passes through Earth's atmosphere. When a piece of rocky debris is too big to burn up and makes it through the atmosphere to reach Earth, it is called a meteorite. Scientists study meteorites to determine the age and type of material found in other parts of the solar system. Meteorites range in size from almost invisible dust particles to massive boulders. Although meteorites may help us answer some questions about our solar system, they often lead to more questions. For example, one meteorite that came from Mars was once thought to contain fossilized microorganisms. This could mean that there was once life on Could this mean that there was once life on Mars? Could huge meteorites falling on Earth have led to an animal extinction? Many astronomers think that the dinosaurs died out when a 6-mile wide meteorite hit Central America 65 million years ago and changed Earth's climate. Scientists in different fields are testing these theories. On page 12, under the top picture, the caption says, visible from Earth in 1996, comet Hyakutake was one of the longest tails observed in the last 50 years. On page 13 at the top, the caption says, meteors in a shower seem to come from a specific area in the sky called the shower's radiant. And the caption to the picture on the bottom of page 13 says, this huge crater in Arizona, United States, is called Barringer Crater. It was formed about 50,000 years ago when a meteorite about 100 feet wide struck Earth.